Hello everyone and welcome to this presentation. I am Juvet Manga, machine learning engineer at the startup Maposa, and for over a year now I've been working on building deep learning language models that can work on the mobile without internet for our application Maposa Smart. And today I will walk you through the steps and process of building an on-device language model. I hope you enjoy this presentation and let's get started. First of all, I think the fastest way to build an AI product as of 2024 is definitely using an API, and the reasons are simple. One, you waste less time trying to go to the market since all the models have already been created for you. Two, get access to a very large number of advanced AI models for any task you want to implement. And three, you get support and constant maintenance by large communities. So those are really essential points to launch a product. But despite these advantages, though it might sound really great, of course, but there's a twist that we should try to examine together. And to talk about that, I'll take a little scenario. So we have Mr. X. Mr. X launches his startup, and in his startup he builds a product. And the app is merely, we can say, a personal doctor, like an AI-powered doctor, which assists users. It works very simply. Users send in requests, like they ask questions, they tell their symptoms, and the application responds to each user by giving them tailored advices and follow-ups and health tips about how they can manage their issues. And in order to be able to do this, Mr. X connected his application to OpenAI, the creators of ChatGPT, and is connected by an API in order to relay the users' questions and use ChatGPT to answer. So that's merely how it works. And since the cost is by users' request, at the beginning for 100 users, Mr. X just pays about $0.85 per month. That's very negligible. That's a good business model. Mr. X can be proud of himself. But anyway, this it's quite okay. First of all, like when you look at it, it seems very okay. But there are actually issues and problems behind this, and we are going to talk about them right now. First issue: the more users enter, the more they request, implying the more they cost. That's something that should be really thought about. So the more users love the service and use it, the more it costs Mr. X. By this, I mean the more they keep using the application and sharing to their friends, the more they use requests and the more Mr. X is going to pay for it. That sounds really crazy. The third point is, what happens if OpenAI suddenly triples their API price? How will Mr. X manage? And four, what about data privacy? We are dealing with individuals' health, very sensitive data, their health information, and they are just shared to third parties like that. Is it supposed to be done like this? So those are the points of concern that should actually be observed as far as API is concerned, and try to think of it again. You build a product to have users, but the more users come, the more you lose money. That really sounds counterintuitive. That doesn't sound really normal, and that's just how it is. Of course, the situation can be avoided in a couple of ways, but among the ways that can be used to avoid the situation, we focus on our main point: building on-device models. And if we're talking of on-device models, we try to see how the need for on-device models is actually going. Why do people want on-device models? Like, the first point is the demand for privacy and security. more and more people start taking like their privacy and their security very seriously. So that's the first point. There's a need for offline first applications that can work without internet. The third point is API really cost. Yeah, is costly. So that alone can account for reasons to try to shift towards on-device models. So in summary, the problems that we have identified: one, privacy concerns; two, continuously increasing costs; three, dependency on an external party; and four, security concerns. So today we are going to focus on understanding the problems that cloud development, that AI, cloud AI models bring. Two, we are going to learn a step-by-step framework for building on-device AI models. And three, we discover how on-device models can save money and build user trust. So I think we are already done with the first point at this level. So we'll proceed with um, understanding the framework. But before going to building the model, I'd like to talk about Produa Smart. Actually, as I mentioned earlier already, I work at Maposa, a fintech startup. It's when building our product Maposa Smart that we found the need to dive towards on-device models. To make it short, Maposa Smart is basically a personal finance tracker. So that's basically what it is. But anyway, the twist we offer is that we enable users to track both their physical and virtual wallets. By virtual wallets, I think of Orange Money, Mobile Money, UBR, and all the like. It works very simply. Your financial SMS are processed by Maposa Smart Wallet and are clearly organized and summarized on a beautifully polished interface. Anyway, before we thought of on-device models, these are the reasons that these are the difficulties we encountered actually. We had problems with internet. We did not want the application to depend on internet. And in order to send API requests, you need to have internet connection. Next point, privacy concerns. We are talking of financial information and we can't just share it like that. So we were supposed to think of it twice. And third point, the API cost, because requests related to financial transactions are very frequent, meaning the more the transactions people make, the more we are going to lose money. So that was a very crucial point. So building on device language models, we are getting now to it. Building on device models, we have three steps to account for. The first part is identifying the task we want to implement and solve. Next point is choosing the tools, the right tools. And the third point is actually manipulating the model itself. One, task identification. When working with language models, there are three main types actually. We have text classification, token classification, and question answering. Those are the three main types of tasks for language model. And to be more clear and explicit, text classification is actually very straightforward. Like we have a text that you give into the model, and from the text, the model tries to guess to what category it is. Like in the diagram you have in front of you, in your poster, and SMS, or when you use your wallet to buy something, it can either be to buy internet connection, that's a payment, it can be to deposit money, it can be to withdraw money, or it can be to send it to a friend. So that's transfer. In this case, we have a payment. So the model will likely try to guess it's a payment. That's text classification. Token classification on the other side, in this case, a text is given to the model, but the model is expected to focus on the entities in the text, not the entire text as in text classification. Can be used for extracting values in a text, which is actually called named entity recognition, as we can see in this diagram. And next, we have question answering. For this type of task, you need to provide a context and a question for which the model should search the answer. So you give the question, you give the context by yourself, like where it's going to search, and the model will understand your question and according to the context give you an answer. So that's how it works. So when selecting a model, remember and always remember this. First point is relevance. Is the task you want to solve, is the task you are seeking to solve in alignment with what you want to use? Ensure it aligns with your app's value proposition. That's the first point. Next point, complexity. Evaluate how difficult it is to actually build and use. Next, we are going to move to the tools used to build an on-device model. As far as the tools are concerned, I will just mention the ones I've been using by myself. So we have BERT, MediaPipe Model Maker, TensorFlow, and Google Colab. So I'll just mention the key points you need to know about these tools. I want to go in depth. So for BERT, yes, all you have to know, and actually to be sincere, the most important thing to note here is BERT is a language expert, and BERT has a smaller size which is called mobile BERT, and it's actually mobile BERT that we use on the mobile phone, actually, that we use to train our model for the mobile. That's the main point to actually note. Here we have a representation of how BERT creates words to each other in a sentence. It's pretty impressive. It's insane. Next, we have MediaPipe Model Maker. And MediaPipe Model Maker is simply a tool that simplifies model creation. It's tailored for mobile optimized models, and it actually speeds up tests and experimentation. So here we have a representation of the steps you follow when you use MediaPipe and when you don't use MediaPipe. There's actually a great difference. Next, we have TensorFlow. TensorFlow is actually a very powerful tool for deep learning. It's a very, very well documented framework. I mean, when you go to the website, you are going to see a ton of tutorials. It has a very large and active community, and it is entirely open source, so you can absolutely feel free to use it to build your model. So that's how it looks like when you reach on the website. That's it, the first thing you see. Finally, we have Google Colab. Google Colab is barely an online development platform. It offers you free computing power to run your model training. It enables easy collaboration if you are working with a team. It actually integrates AI, and this kind of makes stuff very easy to follow out. Like there are some small scripts you can just ask AI to do, and it actually does it quite well. So that's something I use most of the times. I enjoy it very well. And last point, it updates its libraries alone and automatically. But this is quite dangerous because you can leave your work on Friday with a library version and come on Monday and the work doesn't function anymore. And the reason is because the environment updated libraries. So this is how Google Colab looks like when you reach on it for the first time. I, of course, had to encounter with other tools that I could not mention here, of course, but these are some I could add. So now we will move to data preparation. This is actually an aspect I neglected and didn't consider much, but in reality, it is the most important step in building a good model that works. There's this sentence I enjoy. garbage in, garbage out. That's actually the greatest summary that to be made about this. So when you are preparing your data set, there are 4 points you should always consider. One, you should check for the relevance in your data set. Two, generalization. Three, balancing your augmentation. And four, the string splits. What do I mean by all this? The first point, the relevance check. Relevance check. This step is actually straightforward, but not always simple, since it might seem tricky to know which value is actually meaningful or not. Relevance check. Here you identify features in your data that do not add value to predictions, and you remove them. You remove like 95% and leave just a few, so the model will not actually go overconfident. Like you actually try to think and always try to like deduce and not going to memorizing. So this is an example. You have to determine if this transaction is a payment or not. You can bear with me that the transaction ID and the balance are actually values that are not really important to us. So that's actually the point of doing this relevance check. We are going to remove them. Next point is generalization, and here our goal is to highlight the key features and patterns that your model should do. What do I mean? Here, you make sure the text highlights the relevant features only. You remove stop words that are not important, and you ensure data are not so similar, so the model is going to try to think widely and not stay narrow and like think of and only take what has been given. So that's what you don't want to. And an example is actually this. We have a spam classification model. So this is a spam message that you clear so it can be generalized, so that the model wants try to memorize a structure. That's the goal of generalization. The model should not memorize the structure. Third point, balancing augmentation. And here all your goal is to try to make the data set like equal. You don't want it to be too much on a side and less on another one. So that's actually what you want to do here. And to do this, you first have to identify the number of samples for each category. Use data augmentation. And data augmentation is actually to take the class or the samples that are lower and bring them up. That's what data augmentation is all about. And thirdly, make sure all categories have the same number of samples or approximately the same, so that the model won't be too biased. That's it. And lastly, train testing. Make sure no train value is found in the train testing. Actually, the goal here is to have data for the model to learn on and others for the model to exercise on. That's actually the goal of train testing, splitting. And here, what you have to do is one, make sure no train value is found in the test split. That's the first thing. Secondly, you follow the 120 rule. And what does it mean 120? You just have to take 100% of your transform data for train and 20% of the original data set for validation. The transform data set is the one you actually did generalization and the previous steps on. You take that and use it as your train data set, and you just ensure that data are not way too similar to each other. So that's actually what you have to do. Now we are going to move to the model creation and optimization. Here's where we play with the famous hyperparameters of our model, so it learns efficiently. The parameters you manipulate are: you have the learning rate, the dropout rate, the batch size, and the epochs. Sincerely, I try my best not to talk too much about this because it can really become boring and confusing. The first point is the learning rate. Basically, what it is, it's simply how fast the model learns from its mistakes. That's basically what the learning rate is. Next is the dropout rate. is how often the model forgets information to avoid overthinking. That's another feature. Next is the batch size. How many examples the model learns at one, like how many it learns from a single instance. And fourth, epochs. How many times the model will use all the training data set. Thus, if it feels confusing, that's normal. It's just for the presentation. And I actually thought of including some tips on how to manipulate these parameters, but since they kind of feel a bit like too technical, I'll just leave it here for anyone who would like to come back to this later. So that's just this that's it, kind of. So next we are going to talk of quantization very fast. What does it mean? Like quantization is basically just a technique that reduces the size of a model while maintaining its accuracy. That's all what it is. There's nothing special. And here what you actually need to know about quantization is it reduces the size of a model, it speeds load time of the model, it lowers the memory usage of the model, and it maintains its accuracy. That's how impressive quantization is. And before we go to exploiting the model, I would like to leave this the bonus part where we actually try to understand what knocks out. Like you can come back to this part later. We are not going to focus too much here, but I think it's actually kind of important because you can't upgrade your model if you don't actually know what is actually telling you, what the values are trying to tell you. So first, when training accuracy is way too great than validation accuracy, you should start understanding that there's an issue, like what I highlighted. Next, when the training accuracy converges way too early, accuracy from the first epoch to the second epoch, training accuracy leaves some. That's way too big. There's an issue at this level. Third, when the batch size is too small, there's an issue because it doesn't have enough facts to learn from, meaning that it's going to barely just be approximated and just give you confident result why it's not correct. Next, when the training loss is too small, like less than 0.01, that actually means the model is way too confident of himself. And when that happens, that's not something clear actually. So when the model becomes overconfident, that's a sign of overfitting, which is never something to wish to have. It's not something positive. And next, we have test accuracy. When test accuracy is less than 0.50, that means your model is not just performing well, and that's a red flag to watch for. Now, at the end of the training process, you actually have these files available. You have your model in the TF-Lite format because TF-Lite represents the format for the mobile models or models that you can run on edge devices. That's the picture there. So now let's go to mobile deployment strategies. When you're at this level, this is certainly the most complex step to achieve, but it depends on your reality. When you're deploying models for the mobile, you have to take into consideration the development environment, how processing will be done, and how your model will be used. The first point is the environment. You should first of all keep in mind that all native frameworks have a serious advantage. Like they are tools prepared for them, the tutorials available, there is a community, everything is already good. Meanwhile, hybrid frameworks, React Native, Flutter, these guys, of course there are some libraries already prepared, but there's so less resources and support and these frameworks that when you are building your AI model for React Native or hybrid frameworks, you should start thinking of you should prepare for a lot of trouble. So this is a table that summarizes this. Native frameworks have a really good advantage, while hybrid frameworks, and in the case of React Native, because that's what you worked for, you work with React Native, so that's the case I can talk of. It was extremely complex. Up till now, it's not quite easy. There's still a lot of resources that are not being available. But anyway, if you are actually going to engage yourself to, I really wish you come and can actually try to build stuff and make the ecosystem better one. Why not? So, processing and tokenization. Here we are actually going to talk of how the data is prepared for the model. Preprocessing is basically the process of breaking and changing the text into its numerical equivalent. That's just it. Without preprocessing, the model cannot understand our instructions. And for this, I prepared some illustration. Yeah, we have a user who tries to speak to the model directly. Like, what is the best soccer team? And the model responds 1, 2, 3, 4, and none of them actually understand what the other is saying. Like the guy is wondering if this guy is broken, and the other is wondering what the other is saying. And to correct this, you need just a preprocessor. The preprocessor takes the user's answer and translates it and does the reverse. Yeah, the best soccer team is Liverpool. That's the truth. Yeah, and this is just a kind of flow to present how an illustration to present tokenization. You have a text is broken down, and from the tokens that are from the tokens, which is the broken form, you change it to numbers, which are called label IDs. So that's basically what happens. When you have your label IDs and your preprocessed text, that's when you have to go for inference. And inference is just the process of sending inputs to the model and receiving its results and predictions. And these are the steps you can follow for inference. You have to select your text, send it to your tokenizer. From the result, prepare the tensor to be fed to the model. Load your TF like model and send the prepared tensor into your loaded model. From this, you're going to have a response by the model. Anyway, in order to summarize this, I know it sounds like nonsense. Anyway, I have some diagrams so you can actually try to follow along. And I have a case that I mean, when I discovered it the first time, I would have really loved to make a demo of Produa Smart make use of our model, but we are short of time. I could not have the time to shoot and prepare everything. So this is just a picture I took. You have the steps. One, you have the loading of the model. Two, you have the tokens that are being obtained. I took the sentence and broke it down. 3, you have each of the words converted to the numerical equivalent. 4, you have the input tensor that is prepared. So I can't go very deep into the concept of tensors, but you can search it out. And then you have your output at the end of the day, which are basically predictions and scores. So if you can remember just 3 things from this one, anyone can build an on-device AI model. Anyone, I mean any person interested in developing and it's not very complicated. It just needs a lot of practice as everything actually. Next, data privacy is a new concern. Though we don't talk very much about it recently, but it's actually something to always keep in mind. And lastly, APIs should be used carefully, especially when trying to build a real product. So that's just it. We are done. I hope you enjoyed this presentation, or at the very least you learned something. That's what I really expect. And actually, wow, how was living